Hello, my name is James Grant. I'm a technical sports scientist here at Catapult, and my presentation will be an introduction to Catapult data application. This presentation will assume that you've had your Catapult system for a few weeks, you are comfortable with the metrics, and you have a good data set that you want to start analyzing. If you are just getting started with your Catapult system, I would recommend checking out our video, Getting Started with Catapult, over on YouTube. These are the metrics we'll be using today. We'll be looking at player load as a measure of activity volume. Player load per minute is player load controlled for time, so that'll be a measure of activity intensity. Total distance is pretty simple. It is just the amount of distance covered in the session. High speed running is the amount of distance covered above a certain speed threshold that we can set. And high IMA is a combination of all the high intensity events accrued in any direction. So high intensity accelerations, decelerations, and then any changes of directions. So for our first example, I've graphed the average player load on each day over the past week. This will give me a really good snapshot of what our week looked like. I can really easily tell which days were easy, which days were harder, and which days we had off. With this, I can start to look at what everyone did on average on that day, and then I can take out specific players and look and see if they were above average, below average, and then whether we were planning on them having those numbers or if that's something we need to take a closer look at. I can also start to establish patterns based on each day of the week. So if I know every Monday is going to be an easy day, I can start to see what that actually means in terms of player load numbers. Then I can start to use that planning out my weeks in the future. What I've done here is graph the average player load for the last several games that my team has played. I can really quickly use this to compare our games to each other. If I start tagging my games as win-loss, I can see whether or not we are doing more player load, less player load on our wins and losses. I can also start to establish an idea of what is to be expected of our players on an average game and start tailoring my practices to what we're actually doing. So for instance, if I wanted to have a hard practice that is 80% of what we do on a game, I have an actual number to base that 80% off of. I can also use this graph to help me characterize what the demands on my team are against a specific opponent. So next time we play that opponent, I can tailor my training that week to match what we will have to be doing during the game. Player load per minute used in conjunction with average player load will give me a more complete activity profile of whatever session I'm looking at. What I have graphed here is an entire preseason with average player load and player load per minute for each session during the preseason. I can use this graph to see how we ramped up practice at the start of the season, how we tapered going into our scrimmages, and then how we recovered based on our scrimmages. Basically, this graph is a good way to objectively visualize our periodization schedule. With this graph, I have utilized our game tagging feature so that I can check whether or not we are overworking our players before heading into a game. So what this graph is showing me is our average player load and player load per minute for our games, game -1 days and game -2 days. From this graph, I can see that I am tapering down both my volume and intensity on days leading up to games, which is what I would want to be doing in order to keep my athletes fresh on game day. Total distance is a popular metric to work with because it's an intuitive measure that a lot of coaches are already familiar with. What I've done on this graph is graph the total distance for each of my receivers across the last game. One of the things I can do with this information is make an average for the position itself, so I can know what to expect from an average receiver on a game day. I can also look at the individuals within this position, so I can see if there's anyone I may need to take it easy on in practice next week, or if there's anyone I may need to push a little bit harder so that they keep up with everyone else. What I've done here is made a graph of the total distance for one player over the last several games he has been in. This is useful information to know what to expect from a single player, so I can easily tell when he is overperforming or underperforming during a certain game, and I can investigate further why that might be. I can also use these numbers in case my athlete ever gets injured. What they are giving me is a real-time baseline I can ensure that my athlete is able to handle once he's full strength, and it gives me an actual number to work towards as my rehab progresses. Looking at high-speed distance in addition to total distance will allow us to see more information than just looking at total distance itself. Total distance can be accrued at any speed, so a lot of what goes into it can be either just walking or light jogging. And high-speed distance allows us to see how much of the athlete's distance was actually quality that they actually had to work harder to achieve. This is a good number to be aware of when you're planning practice, because you will want to be sure your athlete has enough endurance to handle the total distance demands, as well as the conditioning to output enough of that distance at a high speed. We can also use high-speed distance to build out a running profile for our positions, as we've done here. What we're seeing is the average distance and the average high-speed distance for our wide receivers, our cornerbacks, and our running backs. This will serve as a good baseline when we are comparing individuals to their groups, as well as give us a good idea of demands for any incoming players at these positions as we start to get them ready to fit into our groups. IMA gives us a count of the high-intensity explosive movements, which can help when we're trying to characterize the anaerobic intensity of a session. What I have graphed here is the average high IMA experienced by each position on an average session. With this, I can characterize a profile of what is expected at each position on an average day and use that to determine whether an athlete is having a harder day or a lighter day in terms of our IMA metric. We can also use these numbers to further customize our training to be more specific to the athlete's position. We can break the numbers down even further to view each athlete within the position group. What we have graphed here is the high IMA on average for the individuals within the receiver group for an entire season. As we saw above, a 43 is the average IMA for a wide receiver, but when we break it down to see the variability of each player within this position, we'll see that a 43 for athlete 26 might be considered a light day, while a 43 for athlete 33 is almost double what he is expected to do. Now that we have a solid understanding of what each metric can tell us, we can use them to start answering specific questions. For example, on the graph below, we have the average player load and player load per minute for each of our athletes over the past week. We can use this to see if anyone is standing out or falling behind compared to the rest of the team. And really quickly glancing at this graph, we can see that athlete 23 has significantly higher average player load and player load per minute values. What we want to determine is whether or not this athlete has higher numbers because he is simply functioning at a higher level than the rest of our team, or if he is overworking himself and is headed toward an injury. One way we can make this determination is to see whether this athlete can maintain that high level of output over a long period of time. What we have graphed here is athlete 23's average player load over a few games with a few practices thrown in for comparison. Looking at this graph, we can see that he maintains a high output over the course of the season without any signs of slowing down. As I touched on earlier, player load and player load per minute will give you a good idea of the volume and intensity of an entire practice when viewing the average for every athlete in that practice. We can use these to easily create an objective view of our periodization for the amount of time that we want to look at. For example, in the graph below, we are looking at a week leading up to a game and what our periodization schedule looked like during that session. Another good use of our Catapult metrics is to try and find signs of an injury before that injury actually occurs. These signs may present as a dramatic change in player loading, monotony in our training schedule, or a decreasing output for a similar task. This graph shows us a plot of a player's intensity against their average for the season over the course of about 2 weeks. We can see that even though the volume of these sessions stays relatively constant, he is outputting a less and less intensity over the course of time. This is one of the classic signs of overtraining, and we would want to come up with an intervention to prevent an injury from occurring. That concludes my presentation. Please feel free to leave a comment in the area below. And if you need any more assistance with analyzing your data, do not hesitate to reach out to your sports scientist.